All right, so here's a question that was asked over email, and this is in it's chapter 11. Let me see, it's 11.3, 11.3.43. That's the section that it's coming out of. And the question is, find the sum of the first 6 terms of the geometric sequence. You have 5, 5/4, 5/16, and then the dot, dot, dot indicates that it's continuing on towards infinity, that sequence continues. Okay. All right, now there's actually, I told you all that you're going to get these formulas on the exam. This is what your formula sheet's going to look like. And if I pull it up close, you can see with the geometric sequences that there's a couple of different sum formulas. Okay, this first formula right here, you're going to be using when you're summing, and you're doing it in a finite kind of a way. Right? This second formula right here, I don't know if you can even see it. There's a small infinity right there. It doesn't show it. So it says S sub infinity. S sub infinity refers to doing a geometric sum when it's an infinite sequence. So you have to be able to distinguish between when am I going to use which formula. Okay. In this problem, because they're asking me to sum only the first 6 terms, they're asking me to do something that's finite. Okay. So what I'm going to do is I'm going to use this formula right here because I'm not trying to sum out towards infinity, right? So the formula is this, write it a little bigger so you can see it. S sub n equals a sub 1 times 1 minus r to the n, all over 1 minus r. And you'll be given this on the final. Okay, so the pieces that we need in order to be able to use this formula are we need a sub 1, and we need r, and we need n. Okay, well, the n is given to us as a 6, so that trying to sum the first 6 terms, that refers to the n being a 6. A sub 1 is always defined to be the first term in your sequence, so you can see in this sequence that my a sub 1 is 5. So I know a sub 1 is 5, I know that my n is 6, and then I also need r. R is defined to be the common ratio in a geometric sequence, and the way that you're going to find the common ratio is basically to take the ratio of successive terms. So if I were to, for instance, in this problem, take the 5/4 and divide it by 5, that should give me the common ratio. Okay, division by a fraction is the same thing as multiplying by the reciprocal. So 5/4 divided by 5 is the same thing as 5/4 times 1/5, and then the 5's would cancel and I would be left with 1/4. So my r here would be equal to 1/4. If you wanted to check this, you could actually take the next ratio. You could take the 5/4 and the 5/16 and do a ratio there, just to illustrate this to you. R here would be 5/16 divided by 5/4 if I was going to use the second and the third term in the sequence instead of the second and the first term. Okay, so this would be 5/16. Flip this bottom fraction, 4/5. Notice that, when you reduce this, you're going to end up with the same r, and you should end up with the same r. If you don't, then you've made some sort of a mistake, or it's not a geometric sequence. And here, they've told us that it's a geometric sequence. Okay. All right, so here are the pieces that we're going to plug in, and here's the formula we're going to plug them into, and let's do that. So let's see. Okay, so that's what we're looking at. So I'm going to have, the way I'm going to label this is an S sub 6. That indicates that I'm doing the sum for the first 6 terms. It's going to equal my a sub 1, which is a 5, times my 1 minus r is 1/4, to the nth power is a 6, and that's all over 1 minus 1/4. Okay, what I need to do first is this 1/4 to the 6th power. I believe on your calculator when you do that, let's see what you get. So I get, it's going to be 5 times 1 minus 1 over 4,096. And then 1 minus 1/4 is just 3/4. So where this 1 over 4,096 is coming, basically each of these is being taken to the 6th power. So the 1 to the 6th power is just 1. And then 4 to the 6th power, if you use that on your calculator, you're going to get the 4,096. Okay. So this then is equal to, if I were to get a common denominator here between these two things on the inside, this would be 4,096 over 4,096, because that's equivalent to 1, minus the 1 over 4,096. This is all over the 3/4. Okay. I have common denominators now. I can bring the numerators together. So this is going to be 5 times 4,095, because I'm taking 4,096 minus the 1 over the 4,096. This is all over 3/4. Okay, and I'm going to take the 5 times the 4,095. Let's see what I get here. So I get 20,475 over the 4,096. And this is all over the 3/4. Okay, so what I did here was I took 5 basically over 1, so I just took 5 times the 4,095 to get this number over the 4,096. And then I'm going to take and flip this bottom fraction, because this is, now a complex fraction. It's going to become 20,475 over the 4,096 times 4/3. And then that's going to reduce, so we should check it. I believe 4,096 is divisible by 4, and it is. So 4 goes in here once, and in here 1,024 times. And let's try the 3. 20,475 divided by 3. Yeah, so 3 goes into 3 once, and into this one 6,825. So you're left with this fraction right here, 6,825 over 1,024. And as far as I'm concerned on the exam, you can get a decimal for that. That's no problem. On your online homework, they're going to want it to be in this form right here. They're going to want this fraction. So you actually do have to do the simplification.